Let me show you a useful tool that can sometimes be used when you're doing integrals over rectangles. If you're integrating over a rectangle with sides parallel to the coordinate axes, say between A and B on the x-axis and between C and D on the y-axis, then notice that your integral is going to look like one of these two forms. So you'll have some integrand, f of x and y. If the order of integration is dx dy, then on the outside, y will go from C to D, and on the inside, x will go from A to B. Or, if you're integrating in the other order, then on the outside, x goes from A to B, and on the inside, y goes from C to D. Either way, though, notice that all four bounds are constants. And that's something really important to remember, is if all four bounds are constants, then that means that you're describing a rectangle. Now, here's a special case. Suppose that your function factors in such a way that you can separate the x's from the y's. So maybe f of x and y is equal to a function of x multiplied by a function of y. If that's the case, then the integral can also be factored. The double integral over that rectangle of f of x and y with respect to area can be broken down as the integral of g of x from a to b multiplied by the integral from c to d of h of y dy. Now, before I give you some examples, let me give you an idea of why this is true, and then we'll practice it. So let's say that we have set up our double integral, let's say in the order dx dy. So f of x has been factored as g of x times h of y dx dy, where x goes from a to b and y goes from c to d. Now, on this inside integral, we're going to integrate with respect to x, treating the y's as constants. Well, that means that I'm treating the whole function h of y as a constant. And constants can be factored out of integrals. So this integral from a to b of g of x dx can have this h of x factored in front of it, h of y. Like that. But now, when I integrate g from a to b, I'm going to find an antiderivative for g, plug in two endpoints and subtract. This whole thing is a constant. That's going to be a number when I carry out that integral. And I can factor that number all the way out. So I can bring that whole integral from a to b of g of x dx outside this integral with respect to y. And that's how we can end up with that result. Now, in the next video, I'm going to show you some examples. First of all, to make sure that we can figure out when we can use this shortcut, and also how it works when you can.